So as I was saying in the last video, I was kind of cut off. This idea of epicycles, it explains the retrograde nature, the retrograde motion that is observed um, by the planets. That is, they're going in they're going in these epicycles, and the epicycles are spiraling around and going around the Earth in their own little, in their own little orbits, right? So they didn't really explain why the moon and the it doesn't explain why the moon and the sun are not undergoing retrograde motion. Maybe they just didn't have epicycles. I don't know. Anyhow, it works kind of. It works well enough so that the tables that they had would last for, maybe 100, 150 to 200 years. Okay, because remember, you're using naked eye observations, just looking out at the night sky and predicting where the planets are, and predicting when they're going to undergo retrograde motion and so forth. It kind of worked, and it worked. It's kind of unfortunate that it worked, to be quite honest with you. It worked well enough for this to go from, the time of Ptolemy, which again, he lives maybe 100 or a couple of within a couple of hundred years after the death of Christ. All right, so that's the that's his time frame. So it was still, the Romans controlled most of the planet at the time. That's the kind of world that's the world that he lives in. The thing is, astronomy does not advance very much from the time of Ptolemy for about 1,500 years. So from Ptolemy's time to this guy named Copernicus, who was a Renaissance astronomer, astronomy just kind of, we stick with epicycles. Epicycles are the thing that's taught in schools. Just to let you know, when Harvard University, which I guess was probably started as Harvard College, when that first started in the colonies, they taught the Ptolemaic method, right? Or the Ptolemaic system for the motion of the planets. All right. It's Harvard's that old, was what I'm saying. Okay. All right. So about 1,500 years go by, and remember this. The idea that gets this stuck is that Aristotle, who was again very influential, said that the Earth is the center and everything else goes around the Earth. That's called a geocentric model. There was a guy who actually lived right around the time of Aristotle, named Aristarchus, who said, no, everything goes around the sun, including the Earth. The Earth is just a planet that also goes around the sun. But Aristarchus was not very influential for some reason. And remember, like, if you were argued either way, there wasn't a lot of evidence either way that, without a telescope, it becomes really, really hard to prove this. All right, to prove whether, the Earth moves, or whether, the Earth is the center of the entire solar system, which for the Greeks and for everybody else was the center of the universe at the time. All right, let's go through some contributions. Islam comes along, and there a lot of stuff that was done by some of the Islamic astronomers is certainly the names of some of the different objects. Like, for example, there's a very bright star in the constellation of Orion called Betelgeuse. or actually you pronounce this Betelgeuse, and then there's an astronomical term, and there's many others examples of this called the zenith. That's when you're talking about going if something's straight up from your location on the Earth. That's called the zenith. And also the number system that we use are the Arabic numbers, and they also developed algebra, which is going to help us a little bit later with our understanding of the motion of the heavens. In Asia, there were also contributions. Some of the constellations were used with the mythologies of different parts of Asia. They also, and this turns out to be really important for us. They also made really good, accurate records. So this is during the Middle Ages. Okay, so they're during and before the Middle Ages, but during the Middle Ages they made really accurate records of eclipses, of comets. There's a supernova that was discovered or that was observed, and we even know what constellation that supernova occurred in. We still have we can look at this at the remains of this supernova. A supernova is when a star dies, a really large star dies and explodes. What's important about that is that's how you get the heavier elements on the periodic table. The stars are basically factories for the periodic table. That's where the stuff is created. The hydrogen and helium from the periodic table come from the Big Bang itself. At any rate, they also notice sunspots, and they were actually able to predict eclipses. All right, so those are some different contributions from different cultures around the world. All right, so now again we fast forward from the time of Ptolemy to Copernicus, Nicholas Copernicus, who was a Polish priest. He actually took holy. He became a priest. He was a brilliant mathematician, and he looked at Aristarchus's work, and so he thought about this geocentric model. Now remember, this goes completely against what had been taught in schools for more than 1,000 years, right? The geocentric model was the thing. As well, by the way, just to let you know, by this time, by the time of the Renaissance, the Roman Catholic Church is extremely influential in what was taught in schools and what people thought and things like that. And so even though Copernicus himself is a Roman Catholic priest, he actually kind of goes against what eventually becomes the teachings of the church, right? The fact that the Earth is the center of the solar system, like this Aristotle idea becomes locked into the Catholic Church, right? So the thing about Copernicus that is lost today. I mean, even though he was correct, right? The Earth is a planet. It does move around the sun just like the other planets. The thing that is lost on us today is he doesn't have any really good evidence for the Earth going around the sun. He lives in a time right before, about 100 years or so before telescopes are invented, and he doesn't have any kind of overwhelming evidence. He just really believed. Well, he realized that I mean, one of the arguments that he makes, and it's actually a really good argument, is that the epicycles, right, that were taught to us from Ptolemy, can be explained in a much easier way. Not the epicycles, the retrograde motion, right, which was explained by Ptolemy using epicycles. That is, the planets going in circles within circles. He Copernicus realizes, hey, there's a much better way of explaining retrograde motion. All right. Let's see. Do we have a picture of that? I didn't really want to get into Ptolemy or Tycho Brahe yet. I thought I had a picture. Hold on. Let me see if I can. Oh, no, this is all Copernicus. This is all Kepler stuff. They used to have a slide that showed this. All right, so let me just explain it with words. So if you have, actually, let's go back to this picture. Here, we'll go back to this. Okay. Oh, here it is right here. This is what I was looking for. So I don't know why I couldn't find that. So what Copernicus does is he said, all right, we know that the planets go in retrograde motion. So remember, so you have these background, these are two different constellations right here. There's Leo, there's Cancer, that's Gemini, for example. All right, so the planets pass through the constellations of the zodiac. Over the course of time, they will start to go backwards, which is what we mean by that is the westward motion, and then retrograde motion, and then they'll turn and go eastward again. And so what Copernicus says is, hey, there's a simple, really, really simple explanation for that. And so let's take a look at the Earth and Mars, for example. And he actually, in Copernicus's writing, he talks about Mars specifically. If you look at the Earth going around as the Earth going around the sun, just like any other planet, what's happening is you look at Mars, you're looking at it with respect to some background stars, which are really, really far away. And so what happens is because Earth is closer to the sun than Mars is, the Earth will overtake Mars in its orbit. And so as it overtakes it, that's this retrograde part, right? The planet appears to be moving backwards. It appears to be. Oops, sorry, I'm making the planet go the wrong way. All right, so this is the planet moving eastward, and then as the Earth begins to overtake Mars, it begins to move backwards or retrograde. As the Earth moves along in its orbit, then it starts to move again in the normal, quote, normal way, the easterly way. All right. Again, this happens over the course of months for Mars, but that is a much simpler explanation than these epicycles, which are circles within circles. And then there's, of course, no explanation for why the moon doesn't undergo, if the epicycles are correct, why doesn't the moon undergo retrograde motion? Why doesn't the sun undergo retrograde motion? Right? So the Copernicus really was onto something, but it takes some understanding of the solar system for people to realize that. All right. Now, quickly, so Copernicus again, he wasn't able to predict the positions of the planets any better than Ptolemy did. But it's just a better explanation. It's smoother. It's not clumsy, which is very desirable in science. Now Copernicus knows, of course, being a priest, that this is going to go against the Catholic Church. He waits almost until his death for them to publish his book, and they publish the book after he dies, and it doesn't really make a big difference for a long time.